Welcome to today's Roundtable webcast, brought to you by Microfocus, Attunity, and Pythian. I'm Stephen Fagg, Director of Database Trends and Applications and Unistar Research. I will be your host for today's broadcast. Our presentation today is titled, Taking Your Data and Analytics to the Cloud. Before we begin, I want to explain how you can be a part of this broadcast. There will be a question and answer session. If you have a question during the presentation, just type it into the question box provided and click on the Submit button. We'll try to get to as many questions as possible, but if your question has not been selected during the show, you will receive an email response. Plus, one lucky viewer today will win a $100 American Express gift card. The winner will be announced at the end of the event, so stay tuned to see if it's you. Now, to introduce our speakers for today, Farshad Ghazi, Global Product Manager at Microfocus, Kevin Petrie, Senior Director and Technology Evangelist at Attunity, and Danil Zarifsky, Director of Big Data and Data Science at Pythian. For more information on our speakers today, you can click on the arrows under their headshots. Now I'm going to pass the event over to Farshad.
Thank you very much. And today we are going to be talking about migration to hybrid IT and specifically around cloud. As everybody knows, cloud is a big trend in the market, and we are going to be looking at addressing the cloud using innovative techniques. So just prior to actually moving slides, I just wanted to make a little bit of announcement on our company. And so we used to be part of Hewlett-Packard Enterprise, and we just now are part of a spin merge, and we have joined Microfocus. So if you have seen multiple different logos, that's the reason. But as of now, we are the 7th largest pure-play software company called Microfocus, and I'll be discussing that regardless of which company I'm in, the cloud security and how to protect your data as you're moving to the cloud, which is oftentimes the number one impediment and obstacle in moving your data to the cloud, number one concern. So there are obvious reasons for moving to the cloud, and it is not a question of if I want to. Almost all of our customers at some level are taking some of their workloads and some of their data to the cloud. And we've seen it at various different scales, and some people are still very concerned about security. And they're right to be concerned because traditional security model doesn't really scale well to the cloud and the whole new modern architecture environment that we can see that's available out there. It's also very difficult to set up data centers, and we have seen a lot of failed attempts, in fact, from many companies, and they realize setting up data centers is not as easy as it sounds, and you have to really deploy and employ a lot of different security solutions to make sure you are not exposing your data. So what better way than rely on existing infrastructure that's available with some of the best security experts? Lots of studies show that the public cloud providers do provide a lot of great security in apparatus and tools in their environment, and those are some of the best and most secure environments. However, as often touted, the security in the cloud is a shared responsibility. Security of the infrastructure and the cloud itself is, for example, a public cloud provider such as Azure and AWS, but the security of your application is still your responsibility. And this is quite important that people recognize that shared responsibility. And in addition, we have seen a number of these regulatory and compliance that are coming up, including the General Data Protection Regulation from EMEA or GDPR, that it has very far-reaching impact on not just the European enterprises, but also on American enterprises that are dealing with European Union citizens. So if you're dealing with European Union citizens, then you're subject to GDPR and its steep fines and encryption and anonymization and pseudonymization techniques that you must employ. But as we see also, there are definite requirements for the cloud. Most people don't want to have a vendor lock-in and want to make sure that they can move data freely. And we are going to be looking at one use case from one of our customers that are employing their data and basically storing it and having applications on multiple different public clouds. So what we are really here showing is an infrastructure-centric security and how it is different than a data-centric security. So the data-centric security is what we have been touting, and our proposition is fairly simple. Just make sure that your data is protected. It sounds simple enough. However, it hasn't been done really, and the data hasn't been the focus. Oftentimes, we see there are multiple different apparatus, including the tunnels, which is really addressing the transport of the data. Or we see different things that are addressing parts, for example, access, but not directly the data. So let's take a look at this data-centric approach that is really taking that protection and taking it to the data. So no matter where your data is going, you're going to be making that protection available because the data is protected no matter where it goes. So this is what we are talking about. As you can see, first of all, we are not telling you to do away with the disk encryption or SSL TLS or database encryption and so on. Those are very important security aspects. And there are use cases that definitely require those disk encryptions and database encryption and so on. However, if you're dealing with data and if you're collecting a lot of data, your user data, you want to make use of it. Putting it in a disk and encrypting it, of course, is going to be safe in terms of security. However, it doesn't lend the data to be used in analytics. You cannot actually make use of it. And what's the point of collecting all this data if you can't actually use it? And if you want one piece of information from that entire data set, you have to decrypt the entire disk. Similar thing to the volume-based encryption and folder-based encryption and so on. They're great for certain specific use cases, but in terms of dealing with the data on a day-to-day basis, they are not going to be providing you a good encryption that is also useful for analytics. And SSL TLS is a great example of a very great technology to safeguard your data while it's in a tunnel being transferred, let's say, from your browser to the server. But what happens at the server side? At the server side, the data is going to be exposed in a clear text. And if there's a malware on the Apache web server or IIS web server on the other side of the tunnel, then that information in the clear text can be siphoned off to other parties for nefarious purposes. So what is it that we are actually proposing then? What we are telling here is a data-centric approach. As soon as you get access to the data at the application layer, right there and then when you are getting to see the data, right there at that application layer, immediately replace it with a surrogate value. And that surrogate value will replace the actual data, the sensitive data, throughout its entire life cycle. That is going from application to application, middlewares and so on, and it even gets encrypted and it gets sent into the database in that encrypted format. So if there is a breach by any chance, all the hackers and the bad actors are going to get is the encrypted values, nothing of value, basically devaluing the data for the sake of hackers. That's the bottom line here. And you may ask, so if that is the case, why hasn't this simple technique of encrypting the data been deployed a lot more broadly? Why don't we see that more often in the real cases out there? And the real reason is the fact that the typical encryption is going to make the data unusable in a lot of different applications that are expecting to see a data with a specific format or linked or cannot be put into databases that have very strict schemas. And what we are using, however, instead of that typical, for example, AES CBC mode, is a format-preserving encryption, which is a standard from NIST. It's a NIST Special Publication 800-38G, which describes the format-preserving encryption as a mode of AES. Here are some examples of how you can actually address that, address your sensitive data elements. As you can see on the blue side, on the right-hand side, we are using the format-preserving encryption, or in short, FPE, for the data sets that are coming into our access and our realm, basically. If you have a social security or credit card or email or database, date of birth, anything of that nature, and we have been doing this for a while, you can apply either tokenization or format preserving encryption. And tokenization is very similar to FPE, except that it's randomization instead of a mathematical formula, and it's a recommended method of addressing the protection of your PCI and PAN data from the PCI Council. So in order to achieve the PCI scope reduction, which is often a very major use case for a lot of our customers, then you definitely need to use the tokenization aspect for handling the credit card. And therefore, the systems and applications that are not dealing with the real PAN data are out of scope using the auditors that are coming to check your system. So that's a major use case for a lot of our customers that say that up to 90% of the cost and scope of PCI has been actually reduced, and their chances of passing the audit increased significantly. But as you can see, these techniques, both tokenization as well as format preserving encryption, also give you a lot of advantages. Because, for example, as you can see in a partial case, which is second row in that encrypted values, you can actually, for example, keep the first 6 and the last 4 of a credit card in the clear. That you can still do analytics based on the first 6 without ever exposing the real credit card. Or you can do encryption and maintain the last 4 digits of a social security number in a clear, which is great for your call centers that they don't need to see the entire 9 digits of social security, but they need the last 4 to confirm your account and your access to getting information about your account. On the email, you can see the email still looks the same with an @ sign and so on and the length preserved. And in the dates, we actually maintain relationship between dates. So if you provide multiple different values of dates, for example, a hospital admittance, and then surgery and a follow-up, interactions, complications, drug interactions, all of those things, the date, the delta between those dates will be maintained. However, the actual date will be encrypted using some meaningful formats, including the days that are no bigger than 31 or months that are no bigger than 12 and so on. And you can specify the date range and so on. So there's a lot of flexibility. And these are the kind of things, the kind of characteristics that allow our customers to still run 80 to 90% of analytics using the encrypted values. So that's a significant importance. You don't need to decrypt for every time you want to run analytics, because analytics are typically dealing with a mass data and a trend, not individual social security or credit card. That's the critical and pivotal difference from the typical encryption. And so I was mentioning some of those advantages, but as you can see, in terms of the format preserving encryption, you can join data between different data sets, because our encryption always provides referential integrity, which means if A is encrypted to B, B is always decrypted back to A. Therefore, you can have social security number, for example, encrypted, going to maybe Azure, going to AWS, going on premises, and you can still correlate these different data and tables using that encrypted value of the social security. Look, at this point, you don't have to decrypt to make data correlated and together joined. So that's very important. Also, you don't need to encrypt and decrypt all the time, because you only encrypt the sensitive data elements. Therefore, you're leaving the rest of the non-sensitive data elements in a clear for use very easily. And again, migration of data to the cloud. This is the fundamental aspects of it, how you can actually go to the cloud using this technique. And that's very important in terms of addressing the cloud situation. As soon as you get your data through application server that's running anywhere, you can actually use the format preserving encryption and tokenization, and then share it with other modules, with other applications, or even third party for test data management, for secure collaboration between, a pharmacy and hospitals and so on and so forth. So these are some of the typical advantages of format preserving encryption and the tokenization that we provide. Now, what it means in the cloud, so we alluded to some of those things, and so let's take a quick look at what it what it means. So as of right now, you can have your entire solution in the cloud. That means your application servers, your storage for your data, as well as the key components from our side, which is secure data appliance that is going to be used within this environment, can be entirely on AWS. And you can also encrypt the data that's coming through application servers anywhere. On Azure, it could be on Azure. It could be on-premise environment and so on. It doesn't matter where your application server and your data is coming. And in fact, one of the key and fundamental aspects of the solution that we have is the fact that you can have a single unifying solution across all of your disparate and heterogeneous environments. So if you think about it, a lot of our customers still have IBM ZOS, running IBM mainframe with ZOS, and they still are running Stratus VOS and Nonstop, HP Nonstop, and so on. And they're moving to the cloud. So you need a single unifying solution across all of these disparate environments. Otherwise, you'll have to decrypt and encrypt at the boundaries, therefore exposing the data to real risk at that point. So it doesn't matter where your application, your data is coming. You can have an entirely full cloud solution. However, you can address the cloud and the on-premise environment alike with the same solution. Very quickly, I just wanted to bring one use case from an actual customer that had multi-public cloud environment. And this customer was using Azure for onboarding customers, and they were using the AWS cloud, public cloud, for collecting a lot of sensitive information from cell phones. And this company provides insurance on the cell phones, and they wanted to provide additional value for the big service providers, telcos out there, including, when the phone, for example, the phone OS crashed, what applications they were running, what is the IMSI or IMEI of the phone, and what's the GPS location, battery level, what kind of applications they're running at a time, and so on and so forth. But there's a lot of PII data there, and there are very also sensitive data elements. So they worked with us, and we had this entire solution for them, and they could correlate the data between Azure and the AWS very easily because we maintain referential integrity, and the data sets can be joined and correlated, despite the fact that they were using two separate cloud environments, and that really provided a good way for them to take advantage of each one of these clouds and not expose the data anywhere. So they maintain the data fully and completely in the clear. So in a conclusion, what we are really here talking about is a security solution that spans across the different environments, whether it's a legacy, whether it's a new and modern architecture, and it protects your data, no matter where your data goes in a hybrid environment that we see every customer has. And this gives our customers an ability to adapt and adopt new use cases and business possibility and opportunities with this. So with that, I just wanted to say thank you for your time and pass it back on to my colleagues.
Thank you very much, Farshad. At this point in time, we're going to move on to our next speaker today, Kevin Petrie, Senior Director and Technology Evangelist at Attunity.
Great. Thanks, Farshad, and thanks, Steve. This is Kevin Petrie with Attunity, and I'm very pleased to have the opportunity to speak with you today. I'm working with customers on their journey to the cloud, or more specifically to their journey to hybrid environments that include the cloud, platforms, and on-premises environments. When we talk about taking data and analytics to the cloud, there are some important things to keep in mind. We should step back for a moment and look at the world of analytics. Decision engines, as I like to call them, are really changing. So over the last 30 years, you've had traditional analytics based on batch reporting of analysis of data at rest, based on transactional sources, and you're really taking a historical view. What happened last Christmas season? What does that mean to this upcoming Christmas season? What happened last week? What does it mean to this upcoming week? The modern approach, driven by some incredible advances in software, in available analytics platforms, and in data science, is to apply data science, to apply advanced analytics and increasingly machine learning or other types of artificial intelligence algorithms to recommend decisions or even go ahead and make decisions rather than humans. We've got this real-time processing of data in flight, and transactions are being accompanied by new sources of data. In a lot of cases, data that's coming from physical sensors that underpin the Internet of Things. So taking a predictive view is critical, and organizations more and more want to analyze that data real time in order to predict what's around the corner. So not surprisingly, we've got this shift to modern data architectures in order to make decisions and enable these modern decisions. We've got this move from data warehouses to data lakes. We've got a move from batch to streaming. And we've got the move, of course, from on-prem to cloud, which is what we're going to focus on most today. But I should really point out that, as we all know, data lakes, streaming, and cloud architectures are overlapping quite a bit. Picture 3 very heavily overlapping circles in a Venn diagram. Okay, so the cloud market opportunity. The motivator that we all have to move our enterprises, IT resources and operations to the cloud is to outsource part of the data center, to leverage elastic resources to scale very easily up or scale down as requirements change, and in order to in a more agile fashion and more rapidly develop new architectures and leverage new analytics platforms. The challenges, of course, are making sure that you can efficiently transfer data to the cloud, that you're able to stay mobile and stay agile. If you need to move data from one repository to another within a cloud, that's going to be critical because analytics initiatives and data placement requirements continue to evolve as people go through the iterative, by definition, process of analytics. Another challenge is that you've got these complex hybrid architectures, so maintaining that data mobility can be a challenge. The opportunity, of course, is if you can build efficient data pipelines, you can enable migrations to the cloud, and you can enable agile analytics across cloud platforms. So why are the legacy data integration tools that we've been relying on for 20 more years falling short in meeting the data integration requirements of these new platforms? A few things are happening here. Hand-coded data extraction, transformation, and loading tools ties up very talented programmers that have a lot of work to do. There becomes a human bottleneck. There's also the challenge that most tools serve some endpoints on the source side, some on the target, but the processes to extract and load data from one place to another is going to vary by endpoint type. Another critical thing is that the act of copying replication data, the act of replicating data from production operations can be disruptive. You really cannot interfere with online transaction processing in today's 24/7 global enterprise. And that's where being able to very politely copy the latest data from production and send it to the target is absolutely critical. When we're talking about the cloud, all these things apply. There's also the challenge, which is that you can have slow and insecure data transfer over the wide area network. As a result, there's this surplus of data, often generated on premises, but as you try to get it up to the cloud, you've got a shortage of insights because you can't get all the right data to the right place at the right time. So we're taking a new approach. We believe there's a modern way here to adopt more efficient data pipelines, more automated data pipelines. There are 3 aspects to our portfolio for this. The first is Untitled Replicate, and that's probably what I'll spend the most time talking about here. We provide automated, universal, and real-time data integration, data extraction and loading with some light transformation across all major platforms. Untitled Compose extends this by structuring data, especially in Hive within a data lake, to create data stores very rapidly and update those so that data is ready for immediate continuous use and it's continuously updated. Attunity visibility is going to give you insight on how data is being used, the impact on the underlying infrastructure, and what that means to compliance, to data placement, and to performance. Attunity Enterprise Manager is the umbrella management tool for all this. So right now, for example, if you go into Attunity Enterprise Manager, you can get an intelligent command center for all your replication tasks. And I'll talk through more what that means. Attunity Replicate is a simple, real-time, and hybrid and universal platform for getting data from any major on-premise data repository, whether it's a data warehouse, database, mainframe, Hadoop, or other NoSQL option, up to the cloud, or to any target within the cloud, or even any target on premises. So as you'll see in a few slides, the public cloud platforms, AWS, Azure, and Google, really have all the major options. They have streaming, they have databases, they have data warehouses. So the cloud is becoming this rich ecosystem that is rich with possibilities for people who want to analyze data. When we talk about real time, it really gets to our change data capture technology that can, with zero footprint, copy source transactions and send them where they need to go. The simplicity gets down to end-to-end automation of the replication process from start to finish. So what are we loading to the cloud? Where's all this data coming from? A few things. The lion's share of enterprise data comes from Oracle, IBM, and SAP. Now it also comes from SQL Server, it comes from myriad IoT data points and so forth. But it's important to keep in mind that there's a vast share of data that is ready to be unlocked and ready to be analyzed in innovative new cloud platforms. Oracle, IBM, and SAP represent an incredible opportunity along with their peers, along with Sybase and so forth. We have decades of integration with these on-premises sources, and we can go in and extract data without interrupting for a second the production operations on those critical systems. So when we talk about automation, let's just quickly go through what we're automating. Our goal is to enable data architects or DBAs who do not know much ETL programming to integrate the data that they need. They understand the architecture, they understand where their data needs to be, and they want to open a point-and-click interface to get it done. We will, through a drag-and-drop interface, enable organizations to create the target schema based on source attributes, to perform heterogeneous data type mapping, to automatically transition from a bulk load to CDC so that when you kick in your load to move from, let's say, an Oracle system to SQL Server in the cloud, you can do so with the confidence that Change Data Capture is also going to capture all the incoming updates on the source and apply them to the target upon completion of the batch load and continue with continuous updates so that you now have a target that's going to stay current. We will propagate any DDL changes that might be new tables, new or changed columns to sources. Will automatically propagate those schema changes to the target. And we'll perform light transformations. So there might be certain types of tables, certain types of columns that don't fit the target criteria, and therefore they won't be copied over. Zero footprint. This is really critical. Organizations need to analyze their data, but they absolutely cannot afford to interrupt the production operations that generate that data. We have the lightest and most polite method of capturing real-time changes in the business. Change Data Capture from Attunity has a remote log reader which sits on an intermediate server, and it remotely scrapes the change logs to identify up to the second transactions on these source systems. Maybe it's mainframe, maybe it's databases, maybe it's data warehouses. We'll identify those changes, copy them, and send them to the targets send them over to Amazon Redshift, send them to Google, and so forth. This eliminates the need for intrusive batch replication. This helps you avoid having any intrusive software on sources and targets. And I want to talk more about why this matters. Why does CDC matter? Why does real-time matter? We're working with one of the largest payment processors in the world. They process tens of millions of transactions daily for hundreds of thousands of merchants globally. And they need to run credit checks for each transaction through an outside agency. That's part of the service that they provide to their merchants. By taking the time to do this, they lose time and margin. They did a couple things. One is they moved their processing platform to Hadoop in order to speed things up. The next is that they used Optunity Replicate CDC to enable in-house credit checks at near zero latency. They cut out the need for the outside agency and enabled faster transactions with higher margins. So here you have a case of lightweight, real-time data copies that are translating directly to the bottom line, to margins. So why does zero footprint matter? I want to talk a little bit about what your alternatives are. Oracle Golden Gate is a company we've heard of. They have trouble when it comes to SQL Server 2016. There's a lot of big processing overhead. They have a production base table. They need to create a trigger-enabled CDC table anytime there's a change on the production table, and they need to have a change tracking table. Now they need to have a storage procedure that actually extracts the data. So they've got 3 layers of processing overhead that slows replication and slows production activities. We have a tight relationship with Microsoft and SQL Server for 2016. We don't have agents, we don't have triggers, we don't have extra tables. We just have fast, near zero latency replication, and we're not hurting production activities. We remotely scan logs, we identify, and we copy the transactions, period. There are different methods of change data capture. And I guess the key point I'd make here is that when you're moving stuff over the wide area network, you might want to make a decision. Okay, I absolutely have to have the transactions from my source Oracle database on-prem logged in the same sequence, applied in the same sequence to my Redshift target or to my RDS target. You can certainly do that. If you're worried about ultra-high performance, then maybe you want to batch together certain changes and send them over the wide area network. In either case, this is going to be dynamic multipath encryption so that you will send data in multiple encrypted AES 256 encrypted paths so that you are greatly reducing any security or compliance risk as data moves across the wide area network. We can also stream changes to messaging systems like Kafka, and that, in fact, is an area that we're broadening our coverage when it comes to cloud. So we talked here a little bit about encrypted multipathing. We also can compress data to optimize transfer over the cloud or to the cloud. This is a quick view of all the platforms we support. We are the #1 database migration technology for the cloud. So we have moved more than 36,000 databases to the cloud, and that increases every month. And you can see that there are a lot of different targets as to where you might want to be moving these different data sets. When we talk about cloud transfer, scale becomes very important. And Optunity Enterprise Manager is the way to manage thousands of tasks with a single console and to get a view across on-premises and cloud infrastructures, to get a view across data centers into how your systems are running. And it can also enable you to analyze various KPIs to help with server capacity planning when it comes to the Replicate server, to help with performance optimization. We do integrate for microservices. So through a .NET or REST API, organizations can easily call up a microservice that will execute commands of Optunity Replicate, and that'll happen through this AEM, Optunity Enterprise Manager integration with microservices architectures. We've made an announcement this week about a couple different things here that we're doing to broaden our support for data lakes when it comes to preparing data for usage within Hive data stores, either on premises or in the cloud. We've broadened significantly our support for streaming platforms now to include Amazon Kinesis and Azure Event Hub in the cloud. We can feed any data source to Snowflake data warehouses. Snowflake is becoming a widely adopted cloud target, and we're also continuing to nurture very tight relationships with AWS and Microsoft for Azure. This is a quick look at all the platforms that we support. You can add to this support for comma-separated and tab-delimited files, which is a common way to gather and relay IoT data into different analytics engines. I want to conclude by noting that we are a challenger on the Gartner Data Integration Magic Quadrant. And if you look on Gartner's site, they have public references. We have a number of customers that have gone on to Gartner Peer Insights and reviewed our product, and you can see that we have a higher rating than any of our competitors on overall ranking, on product capabilities, ease of use, and so forth. So this is a big deal because I think that customers agree we're really leading the pack when it comes to cross-platform data integration, especially for cloud-driven hybrid environments. Very good. Stephen, I'm going to hand back to you.
Thank you very much, Kevin. At this point in time, we're going to move on to our final speaker today, Danil Zarifsky, Director of Big Data and Data Science at Pythian.
Thanks, Stephen. Hi, everyone, and thanks for joining us today for this discussion. So what I would like to do for my part of the presentation here is to talk a little bit about the evolution of the data warehouse and how we moved from reporting in a single source to reporting in the cloud, and what challenges and assumptions we have to make when kind of following this progression. So here at Pythian, we help businesses and companies to manage disruptive technologies like cloud, like machine learning and analytics. And we have a wide range of experiences with different types of analytical platforms, both on-premise and in the cloud, which allows me to draw some parallels and kind of see how technology evolved from along the time, and what changes do we see when it comes to the managing and working with the data in the cloud. So if you look at the sort of simplified timeline of what a typical BI reporting at a small or medium-sized company might look like, that it wouldn't be surprising for you to see that the first generation or like very primitive BI platform is just reporting on source. People go to their operational database, and it doesn't have to be MySQL, but there can be any other relational database, but they just run the reports directly on their operational database until they realize that, first of all, they are overloading it with unnecessary queries, and second, there is no tracking of history. There is no way to tell what happened and how certain data changed. So this usually pushes people to adopt a proper data warehouse model, and they might buy something from Oracle, or they might put a SQL Server warehouse at this point in time. And what happens is this infrastructure starts growing around this warehouse. The whole infrastructure of components start growing, like ETL tools and data ingestion tools and reporting tools. And at some point, it's becoming harder and harder to manage this type of environment. What we have seen over the last several years is that the unsatisfaction with a single kind of big box type of warehouse systems led companies and businesses to move to more distributed engines like Hadoop to replace the existing systems. And so not only scale and performance, it's also the ability of Hadoop to ingest any types of data and be able to delay processing to the point in time where you actually want to do something with the data. So you can store data fast, you can process it later, you can scale the system out, and overall, it looked like a good solution to the most painful problems in the BI world. But what we're seeing now is that there are more and more reasons for people to consider cloud as their data platforms. And we here at Pythian do a number of migrations of infrastructures from on-premise to the cloud, and a lot of them are driven by BI and analytics. So a lot of the migrations that we see are specifically driven by the need to move analytics in the cloud. So why cloud is so appealing for analytical use cases? And I know Kevin mentioned a few items already in his presentation, but really what's from our perspective makes cloud so appealing are a few things. First of all, it's time to value. You're no longer required to provision or buy big hardware boxes and deploy them on-premise. You can get instances set up in minutes, and that significantly improves the way and increases the speed at which you can get to the results. Scale and elasticity is definitely a big benefit of the cloud. You can use as many resources or as little resources as you require for any particular job, and you can adjust those resources dynamically. And related to that is cost. If you're not using a lot of resources, when your ETL maybe only running for a few hours a day, if you're in a batch mode, which still a lot of the businesses are, then you can save dramatically on the cost of the system by just not running it when you don't need it. And the last point, I think, is a really important one to consider, because there's a whole new generation of the data warehousing products out there provided by cloud providers themselves. Like there's Redshift from Amazon, there's Google BigQuery, there's Azure Cloud Data Warehouse, there are third-party products like Snowflake, and I think it's really important for people to focus on what are the key features of those new generation data warehousing products, because we believe that they will be driving a lot of the demand for the cloud migrations. So what we see here at Pythian is that if you want to move your existing BI platform into the cloud, or you're planning to build a new platform into the cloud, just relying on existing and old architectures is probably will not be good enough. Like, it doesn't make sense to move your one big box warehouse into the cloud. Interestingly enough, our experience shows that in many cases it doesn't even make sense to migrate your existing Hadoop cluster into the cloud as is if you already have one, because there are better alternatives that exist in the cloud, like Elastic Hadoop clusters available on demand, or specific services like Google Dataflow that are completely managed. And that eliminates the need for having a large Hadoop cluster running all the time. So there's definitely a need to rethink the way the architecture in the cloud for analytical platform will look like. And the way we approach this problem here at Pythian is we think that the warehouse in the cloud will be replaced by a multi-component platform where warehouse will be just one of the components. Like, it's no longer going to be a center of the universe which is doing all the ETL, all the complex computation, all the transformation. It's not going to be the place where you land data before it gets consumed. It will become a serving layer for you to be able to connect your BI tools, and it will only present like this cleaned up and curated view of the data that is more interesting to the BI analyst and business for their reporting needs. Which means there must be some other components in between the data and the warehouse which would allow you to collect, process, store, and manage the data set. And the way we approach this problem here at Pythian is we introduce this kind of layered architecture for the analytical platforms in the cloud. And the key layers are obviously the flexible ingestion layer. There's cloud storage, which all of the three main cloud providers like Google, Amazon, and Azure provide. So it's an object store that provides a very cost-efficient and scalable way to store large amounts of data. And there are a number of execution engines to do your ETL, and we'll talk a little bit more about this in the future slides. And finally, there is a warehouse component, which will take the cleaned and prepared data for you and allow you a SQL access using your BI tools, or allow connecting your internal or external applications to the system. So we're trying to replace one monolithic BI system with a multi-component solution. And the reason for that is we strongly believe that BI, as it is at the moment, is significantly lagging in maturity from, let's say, software development processes, where there's a whole industry around continuous integration and testing and provisioning that makes productivity, which provides significant productivity boost to developers. All those tools are lacking in the modern BI world. And we believe that there is a better architecture that can allow us to achieve the same level of velocity you would expect from a highly skilled software development team to get your BI platform running. So if we look at each of the individual components, I just spent a few minutes on giving some of the options that we see can be used for, let's say, data ingestion in the cloud. I mean, there are numerous options. There's obviously some custom scripts you can write. There are a number of third-party tools and services, and Kevin talked quite a bit about their service for data integration, Unity, which is definitely an option you can use to get your data into the cloud. There are some cloud-native options. There are connectors that both Google and Amazon and Azure provide for their warehouses. But our strong belief here is that there's also a overlooked set of open source tools that can provide a significant increase in the speed to which you can get data ingestion. And here at Pythian, we worked quite a bit with a product called Apache NiFi. It's an open source tool that allows us to do this small portion of just the bigger warehouse-like analytical platform needs is doing the data ingestion. So obviously, when the data is ingested into the cloud platform, there's a number of steps that you need to do. So sometimes you need to do some light ETL, but in many cases, you have to do some significant transformations on your data. Examples are being building a customer 360 view or providing a whole history of customer purchases in a view that's acceptable to the business, which means you need a scalable, you need a scalable engine to do the large-scale transformation. And again, our belief here at Pythian is that SQL, being a great data access language, is actually not a good language for ETL for the reasons I mentioned before. It's really hard to test. It doesn't have any good developer ecosystem support. So our recommendation and the way we deploy platforms to our customers is we're using Apache Spark as an alternative to the complex ETL. You can run it on a number of elastically available cloud services like Datafrog on Google, EMR on Amazon, or Unity Insights on Azure, and it comes with the support for batch and streaming, which means by moving from a kind of a SQL style language to a proper procedural language like or framework like Spark using Python or Scala or Java, you can significantly improve the life cycle of your development, and that will allow you to achieve your results faster and get the data curated and prepared for consumptions. So finally, the last bit of the architecture for the BI platforms in the cloud is some kind of SQL warehouse where you can connect your BI tools to. And we think that the right solution at this point in time is to pay attention to what Google is doing with BigQuery, what Amazon is doing with Redshift, or what Microsoft is doing with the Azure Cloud Data Warehouse, because there's some interesting innovation there, and they also introduced new models for consumption. There's pay-per-usage type of models where you can scale the cluster for a certain workload. For example, maybe a heavy report needs to run, and then you can scale it down and not pay for the rest of the processing power. Google takes it even one step further with their BigQuery, where you don't even have to worry about scaling the service. It comes as a fully managed solution where you just need to get data tables defined, load data into them, and Google will scale everything on your backend for you so you can run queries at any size. So we believe that this component is one of the most critical pieces, and using this cloud-native solutions where companies like where cloud providers put enormous amount of investment in innovation is the right way to address the problem of how would the BI architecture in the cloud look like. So really some conclusions here is that I think everyone agrees that the cloud unlocks new opportunities for analytics. We also see that all BI architectures, they don't work properly just ported as is into the cloud, including even the more recent Hadoop deployments. We also think that warehouse will become just one of the components in a bigger cloud analytical platforms where each layer will do its specific task, but it will do this task way better than the solution that tries to do all of them at the same time. And finally, in the cloud, it's really important to pay attention, close attention from the day one when you start thinking about migrating your BI to analytics to things like how are you going to monitor your solution? What about security and automation? In the cloud, automation is the key. You can't afford, while you don't have to rack up your servers or wait for the hardware to be provisioned, you need to be able to use the power of the cloud through automation. If you don't have the strong layer of automation in your system, then probably you will be spending a significant amount of time just trying to manage all these different layers together. And once data is becoming distributed and it lives in different parts of the system, like there's ingestion layer, there's processing layer, there's a warehouse, the need for the data governance is definitely increasing. And the need to have a good set of business processes around who can access data, who can see which parts of the data and which data can be shared with which part of the organization or third party is really important, because technology, when it comes to data governance, technology can only solve part of the problem. A big part of the problem is actually having a good set of business processes that will make your organization ready for the cloud. And with that, I'd like to thank everyone for joining me today. If you would like to continue the conversation on BI in the cloud, there's contact information on this slide. Feel free to get in touch with me.
Thank you very much, Daniel. At this point in time, we're going to move on to questions from our viewers today. And our first question is for Farshad. Farshad, I currently have a legacy data protection. Will this extend to the cloud?
So that's a great question, and that's a very relevant question. We do know that there are a lot of customers who are going to that zero data center footprint. They are going to embrace cloud. However, the reality is that for a long time, they're still going to be stuck with their on-premise environment. We have customers that are still running COBOL programs, CICS, etc., on IBM mainframe. These are programs from 4 years ago. So it's really, really difficult to move away from some of those mission-critical applications that are still running on-premise, and they're deployed in many, many large enterprises. And these large enterprises often have multiple different sources of aggregation of these systems. For example, mergers and acquisitions and different technology sets at different time periods and so on. So they have basically got this big mixed bag of different environments, and they need to be addressing that. So with the Secure Data Enterprise that we offer, you can actually encrypt your data as is entering your IBM COBOL mainframe application and decrypt it on, for example, an application running on AWS. You can store it anywhere. You can, again, interconnect all of these disparate environments. And that is a key, because you don't want to, as a customer, keep encrypting and decrypting at the boundaries of these systems. If you have a point solution, great. But what happens, that point solution doesn't work out independently in an island anymore. We have all these disparate environments that they need to be cooperating and working on the workloads and working on data sets that are common to them. That is important to then have a unifying security solution that spans across all of them. And since we are working really on the data itself, we are not really looking at anything specific. And as I mentioned, we have solutions that tie the Stratus VOS to IBM mainframe, to HP Nonstop, to Linux, Windows, Mac, all of these environments, and in addition, on a cloud, on AWS, Azure, OpenStack-based, anywhere, big data. That is, of course, almost every one of our customers also has a big data and has a cloud, and they need an interconnection using EMRs or things like that. So yes, it is absolutely possible, and that because the solution really revolves around the data, and then once the data is protected, it can be used everywhere, and with the referential integrity, you can make sense of it and join and correlate the data with other data sets coming from other places.
Understood. Thanks, Farshad. Kevin, our next question is for you. Is one-to-M replication supported through Attunity Replicate?
Hi, yeah, great question. So I'm assuming this means one-to-many replication. The answer is yes. Attunity Replicate can support hub-and-spoke configurations, hub-and-spoke topologies, where you might be replicating from one source to many targets or many sources to one target. We can support either of those scenarios.
Understood. Thanks, Kevin. Danil, our next question is for you. How would you compare performance of an on-premise and a cloud-based data warehouse?
Yeah, that's a really good question. The short answer is it's actually pretty challenging to compare those two systems because it's like comparing apples to oranges in some sense. I think what's really important to consider here is that while you can have a very fine-tuned on-premise data warehouse, which provides spectacular performance numbers, it's really hard to beat the ability of like Google or Amazon to scale the clusters almost infinitely to the workloads that they want to adapt. So you may get better performance for one types of queries for the well-tuned data warehouse that you run in your data center, but for let's say 90% of the queries that you run, the ability to get the resources they need in time is probably more important than the sub-millisecond response for certain scenarios. And analytical use cases usually don't demand that level of latency anyway. So I think the answer to that is it depends on your workload, but really what you should be looking at is, can your warehouse system provision resources that your analytical tools and application need in time and not like a week after it was requested because you had to do some tuning or add indices and things like that. So that is the key consideration here.
Okay, that is all the time we have for questions today. We apologize that we're unable to get to all your questions, but as I stated earlier, all questions will be answered via email. I'd like to thank our speakers today, Farshad Ghazi, Global Product Manager at Micro Focus, Kevin Petrie, Senior Director and Technology Evangelist at Attunity, and Danil Zarifsky, Director of Big Data and Data Science at Pythian.